Hello, hello. I have got to replicate some functionality from code in yours wallet over to the server side stuff I've got in the V5 one-side indexer. And it's been a couple weeks since I've looked at this code, and so I just figured I have to remind myself how all this works anyways, and so it would be a good opportunity to walk through what we got. So, the spv-store is kind of a standalone library, JavaScript library that essentially indexes any transactions you feed it, and it's pluggable with different indexers. And so, if you want one thing to know how to identify ordinal lock transactions, it looks through the output scripts and sees, are any of these ordinal locks? If they are, it categorizes them and pulls out any pertinent data about that ordinal lock. Ordinal lock is it's the market, the global order book lock we've got. So for selling ordinals. So different indexers can pull out different information, whatever. Oh, I just realized my light's not on. Oh, it's too bright. Yeah, it's evening here. It can be evening everywhere. So each of these indexers picks out whatever information they've got, and then kind of that's sort of a second layer over top of just what UTXOs, like the raw bare Bitcoin stuff of, these are my UTXOs. So here's how many Satoshis they are. Here's what scripts they are. And then each of those indexers can kind of layer in data on top of it that says, I found this information about this transaction, so I kind of want to tag it. And then we can search the database and say, okay, what outputs do I have that have this tag? Or also, each of those indexers can raise different events, which are essentially just searchable, very much how Ethereum does events. You log events and you define different fields to be indexes, and then you can search across all those events by combinations of this contract and this event field, indexed event field, and so you can look it up by those. So essentially, it's the same thing. As each one of these indexers can raise different events that happen in there. And essentially, those are something that if you're listening to an SSE stream or a WebSocket or something, you can actually subscribe to those, but also they're fully queryable. And so we can find transactions based on whatever criteria those indexers have identified that it needs to make available. And that's kind of the indexing piece, and that's all implemented the same way on the V5 indexer as well. I'm pointing at my screen as if it's all one screen. Anyways, but there's another piece to the spv-store, which is cleaning up transactions. So transactions get indexed immediately, but they're very much kind of in a mempool state at that point. And so there's a process that goes through and communicates with servers that have Merkle proofs for their transactions. So that might be that you broadcasted it through Arc, and then you want to call the status on that Arc to find out what's the state of my transaction. Similarly, you can, whatever other means come around. The interface I have implemented is for the one-side indexer, but it's very pluggable. So that process of taking transactions that are just in the mempool to getting them to a point where there are Merkle proofs that are proven out, that's what I'm going to have to replicate, but I figure I'll just walk through the whole thing and share it anyways, because I got to refresh myself how it works. So within yours wallet, So this is kind of how we're initiating the SPV store. Now, I have a one-sat ordinals implementation of this whole interface, and so that's what yours wallet uses. So essentially, we don't need to get in the guts of yours wallet, but I do want to go kind of through the how this gets initialized from any project. So you can stick this in literally any web page you want. Or yeah, it can be wallets in apps, and everything stores in index database or index DB within your web browser. And there are no keys in this system. This is really just about making sense of transactions and data within transactions. So when we initialize this one-set SPV object, so it needs a couple of different things. It needs an account identifier. That can be literally anything. Within yours wallet, it is your identity address is what it uses as this account, but it can be any identifier that an app wants to use. Indexers. This is an array of these different indexer objects. So within yours wallet, it is indexing. So this one set indexers is kind of the utility one that helps everything that comes after it. So the order that these things show up in the array is the order that they're processed. So first thing we do is this kind of overarching one set thing that pulls some data out and categorizes some stuff. Then we look for ord lock, which is the sales contract. We look for inscriptions, map data, sigma data, and then origins, which are kind of the other part of, well, whatever. That doesn't matter. And there's also some BSV20 stuff. There's also locks. There we go, lock indexer. So within yours, when you put your transactions through it that has any of that kind of stuff, it'll keep track of all your UTXOs for you and let you query them. But those are pluggable, so anyone can build other ones, and this can index anything that you want them to be. I'll get into more details of those. Maybe not this, but maybe not this stream. Owners. So just like I had talked about on the V5 indexer, owners within yours wallet are all addresses, but it can literally be anything that an indexer wants to pull out of the transaction data and register as this is an owner of this output. It doesn't really doesn't have to be an address, but how all the indexers that are in here right now are, they use an address and yours uses an address. So that's like when we look at an ordinal lock transaction, like the person who, or the address that can cancel that transaction, that is the owner that gets registered from that indexer. So anyways, I gotta stop my phone from booping. Focus. All right. Someday I'll remember to do that. So you register what owners the system cares about. There's a flag for whether you want it to start automatically syncing with remote servers at startup or not. And then we have a passing in the network that we're what? Oh. All right. Yeah, so this is just setting it to either mainnet or testnet. So this is really all the code that yours needs to do at all to get this thing up and running. And yes, there's a lot of configuring, but it's not a whole lot to get it kind of doing what you want it to do. So that's probably the last time we'll look at yours here. So the spv-store itself. Well, let's start with the ones that I don't like that these docs that I have built show up whenever I'm trying to search for files. Not indexers. Pre-config. Okay, so the core of this whole thing is this spv-store class. And really all it does is it kind of provides an overarching control of processes that are syncing in the background and how things are going through. Plus, it provides kind of the user interface. So this is the object you're dealing with. So it's got calls into all the other systems. But basically, there are 4 different services that are implemented. I'm probably going into too much detail for this, but account service deals with a server that will provide some sort of, so maybe it's someone who's running a paymail. This is maybe a wallet server provider that runs a paymail, and a paymail server meaning it's receiving payments transactions on behalf of the owner of the wallet. And so when the wallet comes up, it hits that server to say, hey, what has happened since I last checked in with you about my wallet? So the account service is basically that of give me my UTXOs, or give me my transactions that I've missed since this point, that kind of stuff. Block header service is all about getting block headers, obviously. So because we do full SPV validation in here, we have to have the transaction, and at some point we need to have the Merkle proof so that we can kind of, that's where we get the block height and the index in the block and the actual real world positioning and all the information you need for someone else to be able to trust your transaction. So that's the block header service. Transaction service. This is for an external source of transaction status, which is going to mean essentially where do I look up my Merkle proofs, and yeah. And then there's the broadcast service, which is obviously how you send transactions out. So those are all implemented as interfaces, so anyone who wants to can implement anything. There's also stores. So these are kind of about the databases themselves. So there's a block store, which is what stores the block data, the TXN store, which stores transaction data, and the TXO store, which stores everything else, but mostly that's transaction outputs. All right. So let me just go through. Actually, let's go through them all, since the services, these are just web interfaces. I'm not going to go over the details of these, but I will probably get into when we call into them, what they do. So the block store here. So the block store essentially has one method. No, it has 3 methods. So there's a sync process, which I don't know if this is necessary anymore, but it's broken up into 2 functions for means of being able to exit out of here. So essentially, externally, you'll call the sync function. You can specify whether you want it to return once it's reached the current chain tip, or whether you want it to just keep syncing. So if you say return, it's going to basically sync blocks until it's caught up, and then it's going to return and not sync anymore. If this is false, it's just going to keep there and keep retrying every, I don't know, minute or something, and say, hey, is there any new blocks left yet? And then we've got a is valid root for height. So this is for validating SPV proofs. And then we can call into here and say, what is the chain tip? That's the block store. Pretty simple. The TXO store is the most complicated, but the TXN store is what I need to look into. So I'm going to go into that one last. So the TXO store. So there's actually one more layer of abstraction. So the store is database agnostic. So there's an additional storage layer interface that is built, but everything's in IndexedDB in the one that is implemented there. So the TXO store basically handles all of your outputs. So it allows you to search your outputs. You can ingest transactions into your database. So if you're interacting with a website and you're negotiating a transaction, and then you sign the transaction, you send it back to them, and they give you back a transaction ID, and then you ingest that transaction locally so that your state is updated to the actual state of the world. So this ingest process is almost exactly the same as what is on the V5 server as well. And essentially, this is just keeping track of UTXOs at the lowest level, essentially tagging that with additional data from each indexer, and storing the transaction as something that we need to update get the SPV proof for once it's mined. So when you ingest a transaction, it basically does those three things. And then there's various numbers of queues when you call the sync process on the outer SPV store here. That calls this process queue. And what that basically does is there's a bunch of different transaction statuses essentially in the system. And each one of these kind of is processing a different one of those statuses. So transactions can be queued up to be downloaded, meaning go out to the server and get this transaction. They can be queued up to be ingested. And then when a transaction gets ingested, if we don't have Merkle information yet for it, it goes into this confirms process. We'll pick those up and make sure that we get Merkle proofs for them. And then after we are 6 blocks old, transactions get moved to a more immutable state. And so that's what this process immutable function is. So these things just keep chugging away in the background, making sure that there isn't anything to work on. And then the ingest process, I'm not going to go through too much detail, but essentially transactions can be ingested with a number of different parameters. So essentially, man, got a dry throat tonight. So we need the transaction that we are ingesting. Source, this is really just kind of a tag to say where did this transaction enter the system from. So if you're on a certain website and you get the transaction with them, you can tag it that that's the source of the transaction or whatever. I mean, it's kind of an open field, but it's a tag for this ingestion process. Parse mode. We have 4 different parse modes. One is preview, which essentially means we're not saving anything to the database. We're just figuring out what stuff is. Dependency. So that means that this transaction that we're processing, we're not processing because of any R stuff is in it. we're processing it because our stuff has it as a dependency. And so it basically saves less data and kind of it only needs a lot less data than it needs if it's my outputs. So persist basically means these are my outputs. We're going to save them to the database. And then deep tells it that this is so we can take in beef transactions or transactions whose full tree of parents are part of one package. So I can have a transaction, and for each of its inputs, I can have their transactions and you can keep going back as far as you need to. So if we want to parse that whole tree and save everything within that tree, then we pass in the deep as a parse mode. Resolve parents basically says how much information do we need about our inputs as we're processing this. So if you're doing something that needs to have the parents fully parsed, and those are things that might need their parents fully parsed, and you could end up creating a lot of work. And so actually it doesn't work. It doesn't crawl back recursively at this point. So you don't really have that risk, but you can end up having the system so that it keeps on saving the next transaction backs for all your transactions. And then all those, you got to be careful how you structure it to crawl, because you could end up crawling back way more data than you need. And then this outputs array is an array of which outputs we care about in a transaction. So if you leave it empty, it cares about all of them. But if you send an array, so if I sent 2 and 4 in an array, it says, okay, only worry about saving data for output 2 and output 4. So then this kind of goes through and it loads up all our inputs, marks everything spent, parses all our outputs. So here we're just looping through all the indexers, calling each one of the indexers parse method. And then each indexer also has a pre-save method, which is kind of a hook so this parse is on a per output basis. So you process output 0, then you process output 1, 2, 3, whatever. In the pre-save, you can have an opportunity to look at the whole transaction, not just the things that happened before you, but it's only called one. It's not called for each output. It's just called once at the end for an indexer. That also gives it the opportunity to have let all the other indexers build out all their data for all the outputs. So it can really get kind of a full view of what does the transaction look like. We save the data, we log it. And then each indexer can, when it's processing an output, queue up dependencies that it's telling the system, I know that I need to find this transaction to make sense of what I am. Man. Yeah. Okay. That's pretty much all to walk through on this. Okay, so TXN store is the part that I need to review for myself. So the TXN store handles broadcasting of transactions. That's not what I need. Loading and saving transactions. That's not what I need. Okay, here's what I need. So on my server right now, it's not actually getting the SPV proofs yet. It's not getting the Merkle proofs for all the transactions that it's got in there. And that needs to get there so otherwise you can end up with a risk of stuff that gets in the mempool but doesn't actually get mined. And I mean, that happens every now and then. It's not that big of a deal. But what I need to build are automated systems that automatically yanks those out if they're older than a good amount of time and we still cannot get a proof for them. And then also just the process that goes through and load gets the Merkle proofs and everything. So this process mempool, this is really just about fetching the proof, validating the proof, saving the proof. Process confirms. So this is, okay, this is my immutable state. Okay, so these are the two methods essentially I need to recreate. And there really isn't that much to look at what we're doing here. So I'm getting all the transactions where my status is broadcasted and I am greater than 10 minutes, I think. Yeah, greater than 10 minutes old, and I want 25 of the transactions. We loop through the transactions. I fetch the proof for the transaction. If I don't have the proof, so this I said this in a video the other day as well. The block height in these, if I don't yet know the block height, I'm using a timestamp. And so what that means is when I sort things from oldest to newest, those that will still follow those rules. Also, that cutoff starts at 50 million, which is the same point that that Bitcoin uses. So that actually makes me realize there's an issue here. Oh no, that's not an issue at all. So JavaScript timestamps are thousands of Unix timestamp unit, whatever. They're in milliseconds instead of seconds. So that's fine. Never mind. I was afraid that that difference in precision would affect things, but no, because that just means they're going to be way bigger than 50 million instead of just a little bit bigger than 50 million. So anyways, these things basically get stuck back in the queue with a current timestamp. So we looked at them when they were 10 minutes old. If I don't yet have a proof for it, I now set its timestamp to now, so it will get loaded 10 minutes in the future. If I do have the Merkle path, I verify it, I pull the height out of it, I pull the block index out of it, save the proof, update the status of the transaction, save it. Okay, then process confirm. I'm getting the current chain tip. I'm looking for transactions that are, that's 6 transactions old essentially, because the current height is already 1 and then -5, so 6. So I'm looking for transactions that are 6 blocks deep, and that's just a page size, that 25. So there I make sure that their Merkle path is still valid with the current chain information. And if I do, I set it to an immutable state. Oh, that's if I already had the proof. If I didn't have the proof, which that other process should have already picked up, but then I fetch it. Yeah, same stuff I do in the other one. I update all that information, and then and if I don't have a proof that time, then it's not any good. Then we save it and we loop. Okay, so this is the logic I need to implement on the server. So I guess before I do that, I will go one step deeper into the indexers. So each of these indexers kind of hate all this documentation. I like my code to be clean, but this is it's a project for everyone. So, okay. So an indexer here has got a couple different methods. We've got the parse method, which that takes an index context. Index context is basically the transaction and all the stuff we've figured out about that transaction along the way. So we call it with a context for a specific output and a specific parse mode. Pre-save, we talked about that, gets the whole index context after everything's already been added to it and figured out on it. And then the sync process is really kind of a one-time thing of the first time you start up this wallet, if it's got some place to, if this indexer has some place that it trusts as authoritative server land where I go out and get data, it can do that in the sync call. And that's for like, so the whole system is kind of set up that, actually, I'll move up to this part and that kind of covers the same topic. So there's this index mode. An index mode there are 3 different index modes. There's trust. So an indexer can be running in trust mode, which really means I'm dumb. I'm going out to some server somewhere and I'm trusting it. I don't have to verify. I mean, it's still going to verify the SPV information about that transaction, but parsing data out of it or making sense of what's in it, it doesn't care. It's just getting it from a server. Then there's verify, which is the opposite of that. There's no servers anywhere. Any bit of data about this transaction needs to come from its parents, which are also in the same system. So in verify mode, there's no external feedback. There's no external anything. It's, I've got this transaction. If this transaction tells me it, or if this transaction requires, depends on information from what was parsed out of the outputs that are being spent in its inputs, well, that transaction has to have already been processed. All that information has been pulled out. It's got to have already been there in order for it to make any sense of this. So that's for like validating everything in your wallet. Or there's simple BSV transactions, and that transaction is all the proof you need. That's everything. So I guess that was mostly talking about kind of stateful setups, which I try not to do too many of those, but origins within one-set ordinals and BSV20s both. In order to run that verify mode, you have to have lots and lots of parents. And actually, how yours wallet's set up right now, your ordinals, your normal NFT collectibles, it is validating the whole path back to where that actual image came from. So when you have an ordinal in your wallet, you don't only have that output, you also have every one of the transactions that trace back to where that item was inscribed. And then that transaction has the actual inscription in it, so you actually have everything you need to prove I have this pixel fox. The last one is trust and verify. So this is kind of both. So with trust and verify, this is actually what the ordinals are. It's basically saying, okay, I get this transaction. I'm going to go out somewhere else so that right now I can tell you what this thing probably is. But I'm also going to queue up all the backlog of everything I need to kind of build up the state or the proof for what this thing really is. And it'll queue up all those transactions and they'll start in the background processing and processing and processing. And then that transaction will get processed again with all of that full proof there, and everything is honky-dory. Okay. So that's pretty much all there is to that. And then within each indexer, when we call parse, what gets returned is an index data. An index data has 3 different fields. It's got data, which is anything, whatever data the indexer wants to spit out and store there, it can do that. All the indexers built in here right now are just using JSON for that. Or I should say JavaScript objects, but yeah, because it's being stored in IndexedDB, object structures will persist. Events is an array of events. That's what I was talking about earlier. Of these are things that happen that you can search through in whatever your indexer sees. So if I want to be able to search what the file type is of an inscription, the inscription indexer will raise an event that says there's a type field and its value is application JSON or image PNG or whatever it is. And then the indexer can also declare dependencies. So this is basically saying, in order for you to validate what I am, you need to have this other out point. And in the case of ordinals, that comes from simply the transaction structure. So the indexer looks and says, okay, which input has my Satoshi? And I'm going to register that input, or the output of where that input is pointing to as my dependency. So the system will then know what transaction it needs to keep track of, because it's really all about your UTXOs and what they, well, it can really work either way. I mean, right now it actually is keeping all history, but you can trim it down based on, I need to keep these transactions and their dependencies. And actually, when you back up yours wallet, that's all it saves, is it just saves, these are the ones that my out points depend on. So that's it. So an indexer can return those things, and that's it. So, all right, I'm going to skip now over to, I'm going to move this one. And maybe I'll go halvesies. So I basically need to where do I want to put this? It's probably going to be its own executable. What do we have here? Not blocks. No, yeah, it's going to be its own thing altogether. So let's go. What am I doing here? This is going to be a process that's going to be downloading Merkle proofs, validating Merkle proofs, and I guess we'll just call this TX. I hate naming things. I will, I'm sure, change that at some point in the future. Okay. So I want to just realized I'm wearing my headphones and there's no sound coming out. So why am I wearing my headphones? Stuffy in there. All right, so we have got our transaction log. Where is that? So if I go back to spv-store, the animals are having a romp. Log. Okay, I'm going to go to ingest. What am I logging? TX log tag. Okay, so I have a log specifically for all transactions in the system. And that is just TX. So this is defined in IDX. Okay, so I can still use that same thing. Okay. So I want to. I don't think I have anything that searches transactions. Well, it's just logs. So how do I look up logs? I think that is, oh, I don't have a way yet. But I think I can use my search. All right, I'm gonna make this full screen. Actually, I probably need to make the font bigger. Oh no, that's too big. Okay, so if I go search, doesn't matter which one. So this is just gonna go against pass in the key. Oh, search key. Oh, that's no, that's only about events, or that's only about it's about logs. What's the difference? There's some reason that I had a difference in the system between logs and queues. So if I go back to, let me just go to the Redis one. P Q. I definitely have different tables. I have queue table and a log table in the Postgres one. Oh, but these are completely different things. I'm not sure why these are different. This has tag member score. I think it's simply just to differentiate two different types. So queues were originally something where things came into the system or one process is putting a thing for another process to be able to work on. And logs were just like, I've processed this transaction. I've processed this transaction. But those really are exactly the same thing. And as this has evolved, I wonder if these really should be separate things or if they should be the same. I think they should be the same. All right, major refactor on the fly. So where do I call log? Simply when I ingest. And I save it as a global transaction one and as whatever the tag this was running at. And when I broadcast, I keep track of the fact that, oh, I forgot I did that. So why was I setting a minus score? Oh, I think I only, ooh, that might be cache.set. Huh. think that's right. But luckily, the process I'm doing right now is the first thing that's going to use this. So no harm done. Okay. So these logs are just basically saying this thing happened. Now I can still update the status of that where when I go from that's also where I'm keeping track of everything in the system. The score is the block height and block index or timestamp. And so the process we're really working on is converting those timestamps to block height, block index, which is the score of this table. But okay, so where do I do Q? Where's my, oh, geez, I just passed it like 4 times. So owner sync will say ingest this transaction. And subscription will say ingest this transaction. I think logging and queuing are the same thing. Okay, so let's go to my TXO store. Do I like? I think I like NQ and DQ better, but then I still need the score. So score is basically saying it's an exist check. Basically says, does this exist and what is its either timestamp or height and index? Log, D-log, score. Yeah. And then let's go to So what's kind of interesting about the system is in some ways, it's really just a way of tying tags to out points. That's essentially what the whole system is. But it's kind of evolved more and more into this just super, super simple, because everything is really just pointing to an out point. And then from there, that's where the data and the events and everything else are stored. But pretty much every way that you want to categorize anything is just, well, I guess in this case, we're talking about transactions, not out points. But it really doesn't matter. It's still just a string. Okay. Then I want to go to the other one. Okay. So what did that break that I need to fix? Probably a better word than D-log. That's kind of a generic, I mean, this is the whole store, so remove log, delete log, del log. It's pretty much what I have. Just it's 1 L instead of 2. D-log it. I like it. Okay. Is that it? No, right here. Oh, that wasn't working yet anyways. I had other stuff broken there. But if I can fix it quick, I might as well. That's literally it. Log. Log. All right. Well, that was easy removal of some redundant code. It also means that in my SQL, I do not need the queue. Got a nice little table here, or little schema. Okay. So go back to my main here. So what I'm doing is searching logs. So I need a log. Let's go back to spv-store. Get logs. And I need a tag. Oh, look at you being all helpful. Search result. I guess that is. Wait, do I already have this? Huh. Oh, that's an out point. Well, that's really the same thing. This is literally the only place this is used. Okay. Apparently, I've been down this path before. Now, the next question is this better to be placed on, go back to search again. Search is all about, well, on Postgres, oh, do I want to collaborate even more? Holy cow. TXO search, we've got a key. Yeah, I don't want to, I think I'm getting too much into abstraction here if I go that route. So TXO search is really about identifying out points to a given event, or with these are really more about transactions, and that's what the difference is. These members are almost always going to be out points. These members are, well, it really doesn't matter. It's either an out point or it's a transaction ID. It's kind of nice because the out point is the transaction ID, but with just more qualifier on it. That was the wrong cup. It had nothing in it. Okay. So get log, well, on the Redis side, though, I can actually use the exact same search. Feel like I got redundancy. Would I ever need? No. Huh. I think we're going to unified log structure. Basically, this is just my tag is essentially the same as my key in. Maybe I shouldn't call that. Maybe I should call this search key, which really means it's that table with this name. Because really, this also continues to mimic the Ethereum way of doing things. Of you have events that are in logs, which together they are event logs and whatever. I'm just going to be using it for kind of state of the system stuff as well, but actually, I think that's a good thing. So let's see where TXO search was used here. So this is going to become logs. This is going to be real easy. Oh, I'm going to have to fix all the logs ones though too, because I renamed that field. That would never have worked. Huh. All right. You got to fix that. Actually, nothing hits this endpoint at this point. I don't even know if I'm going to expose that endpoint. Okay. So search TXNs. What is this? Oh, I already. Oh, no. Okay. That's unrelated. Where did I put? I guess it's. Well, I guess I'll just keep going through this way. Okay. So then I probably should have done this before I did that, but let's look for from logs. Okay, that's what I just did. So then we have dlog. Okay. So this needs to be search key. Dope. Okay. Log score. I like it. And then my search is all going to be against logs. Okay. Keep simplifying. So that's unique data. That's unique data. That's catch-all data. Unique data. Unique data. Okay. Technically, I could throw that in there as well, but that doesn't fit. Don't want to go too far. Okay, so got logs we've already got. So now my search is actually going against my logs. So I want to go search. So I'm going to go return an error. No. Oh, it's just complaining it isn't used yet. Okay. So I want to search transactions. Oh, no, I don't want to do that. Search. No, I want to just search. Shoot, that's not something I added to my interface. Oh, search out points. This is what I want. Which might mean I want to rename that. These are really the keys. Well, no, these are the members. That's now the word I'm using, I guess. Dope. Server. Wrong server. Get logs. Okay. Guess I got to implement that. What am I looking for here? Q is where that would be. Oh, that one doesn't either. Get logs. Oh, that's why. I'm going to use search for that. Okay. Jeez, what Pete's. Suppose it's almost midnight. That's my excuse. So what I really just did there is kind of, well, I already said it. Never mind. I don't need to be explaining stuff too far. Obviously, I'm not trying to tutorialize this. I'm just trying to document what I'm doing. But at first, I kind of want to give people the opportunity to get up to speed of the thought behind things. Maybe I'll keep doing that. Who knows? This is all for fun. Okay, so I don't need that. So search members. Oh, I wasn't able to do that because there's a too late. Still won't let me do it. Server still has an issue. Other server still has an issue. No, it doesn't. Maybe it just needed a second to catch up. You piece of crap. TX verify has errors. Oh, geez, oh Pete. Silly me. Oh. Oh. This actually isn't going to work. Oh, search is not public. Where do I? Oh, it's only, okay. So I need the scores back, not just the string array. So because every record in my database here essentially has a pointer to a thing and a score on that thing. And those are both ways that, so you can find a thing score and you can sort things by the score to find the thing. And so I've got two different functions here. One that just gets me the thing, not the score. And then I've got search TXOs, which gets me a whole TXO object. I really just want the key. I just want the member. But with its, I just want the, I guess it's the result. I want them both together, which is where I created this object. So I'm sure it was for this purpose. Where was that? Where was that? That was in TXO store, search result. And I wanted this private because it's actually returning Redis objects. So I probably need just, I guess it's just going to be search TXO, search TXNs. Search TXNs is a much more in-depth process. That basically finds all your stuff you've got logged and does intelligent stuff into whether they're transaction IDs or whether they're out points, but it kind of summarizes everything at the transaction level. So what it returns is a transaction and transaction ID basically, and which individual outputs were indexed as their own events as well. Oh, I feel like tired is not the way to do these. Oh, no, that's right. That's not going to be on here. Search is its own thing. So I really just need big S search to go along with little s search. Actually, oh yeah, because I don't want to have to loop over them. Yeah. I don't care about any of that. I want results error equals search. This is not going to be a Redis Z. This is going to be a search result, and I'm going to move these over here. Oops. That's the Redis one. I want. Oh no. It was right where it's supposed to be. Okay. Well. Yep. Good job, Copilot. Love it. That's exactly what I want. So let's just map the Redis Z array into my native object. It's funny is the values are called the same thing. It's just this is an interface, and I really don't want to be passing interfaces back in. Well, actually, I can't. For Postgres, it needs to be a string. Unless I want to way overcomplicate it. Okay. Boop, boop. Okay. So, go back here again. Main. Oops. That's what I meant. Okay, so I need a idx.searchconfig. So I want to find the key is going to be idx.txlog tag. Okay. So I got my search key. Got my, what do I need here? So I want from as, okay, so what do I call that? idx.height score, or my height is 50 million. So basically I'm searching this transaction log for all transaction whose score is greater than a height of what would be a height of 50 million. So that's going to give me everything that is marked with timestamps. What else do I need in here? Limit. Yeah, let's, I don't care for now. Let's just go 10. Reverse equals true. No, I want it from, oh, get out of there. Include TXOs. No. Include, no. Okay, that's it. Okay. So this should give me Okay, so I have got, well, this, I don't want this to be called TX. I'm going to call this pointer. Okay. So what I want to do here, I want to load up the transaction. Yep. For the pointer member, that looks good. No. I wish you could just like take part of Copilot's suggestion and not all of it. That would be nice. It's funny. I used to be really not a fan of nesting logic structures, but I'm actually finding, I mean, mainly, especially when you get way, way too nested, I'm finding myself doing it a lot. I think it makes it so much easier to follow. And I actually like too that, like, I'm sure this is intentional, but I've just never thought about it, is that kind of the layer where you declare a variable is the full scope of that variable. So as soon as you get out of that, it cleans up, and that's not rocket science. But it's just something about doing these indents just made it a lot clearer in my mind what's happening. Okay. Not enough arguments. Oh, with proof. Yes, that's the whole point of why I'm doing it. Okay, so if tx dot Merkle path equals nil, oh, okay. I need to have a max. Can I do a max in here? No, this is all about stepping through for a certain number of records. So what I'm concerned about here is I don't want to be getting things that are, I don't want to be just because I'm going to be looping through this data set of transactions to validate. And if I hit one and I look up and I know it doesn't have a Merkle path yet, I don't want to just the next loop through do that again. I want to be able to basically boot that that timestamp up. But so here I can adjust. That's not a. What's my search config got? I probably need a 2. I think I probably need a 2. And then that means I got to get back into this logic again. Actually, oh yeah. I don't want to think about that right now. I'm just going to process the whole thing and then wait, and then process the whole thing and then wait, and then I can optimize this later. Actually, I might do this all later. I am running out of steam again. Let's just do the true case. So I want to go tx dot Merkle path dot verify. So I've got my tx dot txid dot string and my chain tracker. I need to have an instance of the chain tracker. What is my chain tracker? I feel like I built one of those out, but I don't remember where. Oh, well, I mean, this is where I get the proofs. Where do I get my, and I block. That's right. Start chain tip, sub, chain tip. Uh-huh. Okay, so I've got all the data. What does a you know what? I can just click through to that, I bet. Chain tracker dot chain tracker. I can't do it that way. So I really just need needs to be an interface though. That's kind of icky. So I gotta have to have a struct that's got that method. I guess I'll just put it on my. That's going to be dealing with block data. It's nothing to do with my TXO star. It's nothing to do with Redis. I think it's an issue for tomorrow or Monday. Thrilling video as always. I'm gonna go to bed. Au revoir and all that stuff. Bye bye.